let's do chapter 6. Chapter 6 is about continuous probability distributions. Okay, what is the difference between continuous and discrete probability distribution? In continuous probability distribution, you have the variable that can take any value in the interval. So, the f of x is nothing but the probability density function. It's not the probability function anymore. It's the density function. Okay? This is f of x, this is x. And really do not matter what is the shape of the distribution. We are dealing with areas in this case. And the whole area has to be equal to what? To 1, because there are no other possibilities. Now, in a continuous probability distribution, the probability that the variable takes a particular probability that the value takes a particular value is equal to 0, because we are dealing with areas, and in one point there is no area. So the probability that x is equal to x0 is equal to 0. There are no areas. In continuous probability distribution, we have to deal with areas. So we have to say, what is the probability that a less or equal than x less or equal than b? Then we are dealing with probabilities. This is a and this is b. And we have to say, well, the area inside here, this is the probability. So we are not dealing anymore with that. F of x is the probability distribution. F of x is now the density distribution, and we are dealing with areas under the curve. The most basic continuous probability distribution that we have is what is called the uniform distribution. And it's a function that has value in a interval, a and b. Now, we know that this area over here has to be equal to 1, right? Now, what has to be this value over here? What is the f of x? Since this value is b minus a, this height has to be what? 1 over b minus a. So my f of x for this uniform, that is called the uniform distribution, is equal to 1 over b minus a when a less or equal than x less or equal than b and 0 elsewhere. Okay? The expected value in the uniform distribution is a plus b divided by 2, and the variance of this distribution is equal to b minus a squared divided by 12. Okay? That's it. That's the easiest one, the uniform distribution, that is, has the same value over the particular interval. Okay? So the function has no value. Now, we want to know, for example, what is the probability in the uniform distribution. Well, we have to consider the areas. That's it. Let's do problem number 1. Problem number 1 tells a random variable x is not known to be uniformly distributed between 1 and 1.5. So this is number 1. 1 and 1.5. That's the only range or interval where this variable is defined. Show the graph of the probability density function. Okay, this is 1, this is 1.5. and this is the graph. Now, what is this value over here? What is f of x? We know that this is what? Over here we have 0.5, right? Because it's the distance between 1 and 1.5. This is the length of this rectangle. What has to be over here in order for this to be equal to 1? Remember, the whole area has to be equal to 1, so this number has to be 2. Okay? Compute x, the probability of x equal to 1.25. Okay, this is A, this is B. What is the probability of x is equal to 1.25? Okay? Remember that I tell you that this is 1.25, right? What is this probability? 0. There is no area over here. All the continuous variables, the probability that is in a particular element, the particular number is equal to 0. So the probability of x is equal to 1.25 is equal to 0 because there is no areas. C, probability that 1 and 125. 125. This is C. So they want us to know this is 1.25 because this is 1.5. And from 1 to 1.25, so we have to know what is this area over here. And that is the answer. What is this area? Okay, what is the length and the height of this rectangle? Okay, this is, let me draw the rectangle over here. This is 1, this is 1.25, so this length over here has to be equal to what? 0.25. And the height, we know that the height of this rectangle is 2. So 0.25, then this is 0.5. The probability that this random variable is between 1 and 1.25 is 0.5. And the same token, what is the probability, the 1.2 and 1.5? 1.2, because we go 1.5. So really what this is asking me is, I'm going to erase this part. 1.2 is over here. And they are asking me what is this. They are asking me, and I need to know what is this area. So if I draw it again, it's between 1.2 and 1.5. What is this? What is the length of the rectangle? 0.3. And this one is 2. So it has to be 0.6. And that is the answer. Now, the normal probability distribution, I'm going to do it in a different video. So I'm going to cover the exponential distribution. Okay, and also for the expected value and the variance, you just apply the formulas. You have the value of the B and you have the value of A, and the rest is pretty easy. Exponential is usually is time between arrivals. This is the opposite of the Poisson distribution. Remember, the Poisson distribution, we are dealing with the number of customers per hour. Well, this one is the time between arrivals of the customers. It's completely the opposite way, if you will. get into this. The f of x of the function, I really don't care about what is f of x, except to tell you that f of x is used only to get the mu. But what the function that is important is the formula 6.5 on page 254, and that is the cumulative probabilities, because this is the one that are going to give us the probabilities. The probability that x is less or equal than x0 is equal to 1 minus e to the power of minus x0 divided by mu. This is the formula that we are going to use to calculate probabilities, not f of x. Okay? Now, unfortunately, we do not have tables for the exponential distribution, so we have to do what we have to do. Okay? And this is the function. This is f of x. This is x. More or less, the shape of the distribution is like this. But we are not really interested in f of x. We are interested in this particular function that gives us the probabilities. The mean is mu, and the variance is mu squared. Okay? So if I ask you what is the mean is the same parameter, and the variance is mu squared. Okay, let's do one problem for this. That's it. Let's do problem 32. 32. Consider the following exponential distribution. What they are trying to tell you here is that really my mu is equal to 8. That's why they give us the probability distribution that you compare it to the formula 6.4, and then you see that the mu is equal to 8. Now, find x less or equal than 6. Probability x is less or equal than 6. And that is, use the formula 1 minus e to the power of minus x0. What is x0? It's 6 divided by mu, 8. That's it. That's it. That is 0.5276. B. What is the probability that x is less or equal than 4? It's exactly the same. 1 minus e to the power of 4 divided by 8. And that is 4 divided by 8. Is 0.3935. C. Find the probability that x is greater than 6. Okay, now we have these that give us, this is 6, okay? And this function gives us the left side of the distribution, right? And we want to know the right part of the distribution. This one over here. So, since everything has to be equal to 1, we know then that is 1 minus this is equal to 1 minus the probability that x is less or equal than 6. So it's equal to 1 minus, and we already have less or equal than 6.5276. So that is equal to